today. We're focusing on vectorized programming, and of course, here you can then plot this. Another thing that I often do is when I run these loops, I call this something. I have my standard. I call this reds, which is basically stands for my strategy returns, and then I go reds dot in a kilomillimeter sun plot. I can run it, and it just does the same thing. Now, what's good is if I do this, I can do something like print, and then I go reds dot mean divided by reds dot std times 16. It's the annualized risk-adjusted return, also called the Sharpe ratio. Yeah. So I can actually look at the different Sharpe ratios of the strategies. And, interestingly here, we've got one with a Sharpe ratio of 1.2, which is surprisingly high.
I think that's the time, no?
Oh yeah. Okay. Yeah, I was wondering. Yeah, that's the time, of course. I'm like, how does this come about? Yeah, that's the time. You're right. Thanks for checking that with me. So obviously the Sharpe ratios for these particular strategies are not very impressive, as you would expect. Like we just literally plug something out of thin air. But that's not really important. What's really important here is that I give you effectively tools to do research, and to do research in a very efficient and effective way, right? So in order to be able to really leverage all the power that you have as a quant analyst, because if you run slow back tests, you wait around for days and days and days, your results are never going to be as good. Okay. And so if you can go quickly through, and we can go quickly through and say, well, this moving average crossover thing is really not phenomenal, or this moving average divergence. So we already established that when we actually do a sort of when we cap our drawdowns, and it's in some sense a bit better. So we get an improvement. But what's important here is that we can actually we have a tool to really quickly test different things. All right. So now we could do all the parameter improvements and so on. Like in this case, there's really not an awful lot that we can do. Like we've got one of these backtests with 0.48. It looks a little bit, we could reverse that, but still not very impressive. So that's really interesting. So we've got the tools now to do really fast stuff. And the next thing we want to do is, well, what is it actually that we are doing here, when we say use a moving average and so on? Because why does this stuff actually work? What's the underlying mechanism of why trading works in general? Okay. And in order to understand that, one of the really interesting tools that we can use is simulation. So we can, for example, simulate price data.